Okay, in this problem, I've got a crane that's supporting a 1,500-pound load. Okay, and for our cases, we're going to assume that this X is all the way off at the end, which is at 12 feet. Okay, which is a little different than where essentially this tie rod is connected to the center of the other beam, which is 10 feet away. Okay, so the load is acting way over at the edge of the beam. This guy's connected essentially 10 feet away. Okay, we want to find the normal stress in this tie rod, BC, and then the shear stress in the pin at B. Okay, so the first thing I need to do is do some statics, and I need to figure out the force going through this rod. Okay, because this is a two-force member, so it's just going to have an axial load going through it. Okay, so I draw my free body diagram. I've got pin at A, got my 1,500 newton force, and then that BC. So the only thing I'm looking for is the force through BC, so I can just sum the moments about A. Okay, again, the tie rod is 10 feet away. The vertical component is just the sine of 30. And then I have that 1,500 pound force acting 12 feet away. Okay, so that's what X will equal. So because of that, I find the force going through that tie rod BC to be 3,600 pounds. Okay, once I know that force, I can easily find the normal stress going through that rod just by dividing that force divided by its area. So I take that 3,600 pounds and I divide it by the area of that tie rod, which has a diameter of 3/4 of an inch. So pi over 4 times d squared is the area of a circle, okay, or pi r squared, but in terms of diameter, it's pi over 4 d squared, and I get 8.15 ksi, which again is 8,150 psi. Okay, now to find the shear stress at B, we have to notice what's going on right up here. Okay, which is I've got this 3,600 pound force acting through this tie rod. Okay, now notice the way this goes. To balance it out, I basically have half of that as shear forces. Okay, basically I'm like cutting this pin in 2 points, and I have half of that 3,600 going on each side. We call that a double lap joint. So rather than taking 3,600 divided by the area, I take 1,800 divided by that area because of, basically this is my free body diagram of what's going on there to find that internal shear load on the pin. So I take 3,600 divided by 2, and I divide that by its area of the pin, which again is a 5/8 diameter circle, so it's going to be pi over 4 times 5/8 squared, which gives me a shear in that pin of 5.87 ksi, which is 5,870 psi. Okay, so again, you start with statics. Once you get those internal loads, the internal axial load, the internal shear force, you can apply that to basically divide by the cross-sectional area to get either the normal or the shear stress.